Okay, this video is 6.2 again, but this is including variables, so go ahead and pause and see how you do. The first one, you have like bases, but you also have power on a power, so you do have to start there. So when you have a power on a power, you multiply. 3 times a half is 3 halves, and then x to the 1/6. And now because you have like bases, the base stays the same, and you can add the exponents since you're multiplying. And I need common denominator, so that would be 6. So this will be 9, 6, oops, plus 1/6, which is 10/6, and that reduces to 5/3. And then because it's variables, I don't have to think about simplifying because I don't know what x is. Okay, the next one you have a whole lot of things. So you have d's, e's, and f's, so I can simplify those. And then 15/25, you just treat that like a fraction. So of course I can divide both of those by 5. So that's going to reduce to 3/5. And then I'll go to my d's. I guess, well, you could do a couple things. This is a negative exponent, so I could bring d squared down to the bottom and then add that to the 1/3. Or I can just subtract these, but -2 minus 1/3 is -2 1/3, so it's going to end up down at the bottom anyhow. So I'm going to just, I'll write that d squared times d to the 1/3, and I'll simplify that in a second. My e's, I'm going to make a common denominator, so this is going to be 5/6 minus 4/6, and that's 1/6. So let me say that again. Common denominator would be 5/6, and I'm subtracting since I'm dividing. 5/6 minus 4/6 is 1/6. And the f's are already common denominators. That's nice. So 1/2 minus 7/2 is -6/2. And I'll take care of that in the next step. So my e is fine. And my my d's, I'll start there. I can add those together. So 2 I need a common denominator because this is technically 2/1, right? So as a third, that would be 6/3 plus 1/3, which is 7/3. And then my f, this is really -3, but it has to be moved down to the bottom, so that would be f to the +3. And that's your answer. Okay, the next one you have is the third root of 32x cubed. So again, you might think about thirds. So 2 to the third is 8, which goes into 32. 3 cubed is 27, which does not, and 4 cubed is going to be bigger. So I would break this down to 8 times 4. And x to the 4th is x cubed times x. And then I know the third root of 8 is 2, and I know the third root of x cubed is x, so that leaves me inside the third root with a 4x. And that's simplified. Now for those of you that like to take this and break it down, you can certainly do that and say, well, I know 32 is 8 times 4, so that's going to be 2 times 2 times 2 times 2 times 2, and x to the 4th is x times x times x times x, and then circle all your groups of 3. So here's a group of 3, so you bring that out. Here's a group of 3, so you bring that out, and then what's left? 2 times 2 times x, which is 4x. Alright, then you have the 6th root, so I'm going to break everything down to 6. So x to the 12th is x to the 6 times x to the 6th. Y to the 8th is y to the 6 times y squared. And z cubed can't be broken into a 6th. So now for every 6th, I bring one out. So here I'm going to bring out a 6th and another. So I'm going to bring out an x and another x, which will be x squared. Here I have a 6 with my y's, so I bring one of them out. And then inside my 6th root, everything is that's left over. So y squared and z cubed. And again, if you wanted to write all of those out, although that would get pretty long, and then circle your groups of 6 you can certainly do that. Okay, fifth roots. So here I'm going to break down e to the 7th as e to the 5th times e squared, and that makes a 5th, also makes 7, right? F to the 15th is f to the 5th times f to the 5th times f to the 5th, and then every 5th you bring out 1, so I'm going to bring out an e, and on the denominator I can bring out 3 f's, which is f times f times f, so f cubed, and that's still in the denominator, be careful. And inside the 5th root I only have an e squared left. I guess I didn't need to make that 5th root so big, right? And that would be your final answer. Alright, then the final one on this slide, you have both third roots, so you could, yeah, you can multiply these together, right? But I also look at things individually because I know the third root of 8 is 2, so I would take out that 2 first, and I also know here that I have the 2 third root of x to the 4ths, and then I'll glob maybe my x's together. So I'm going to multiply these now. 2 times 2 is 4, and I can multiply them because they're both outside the radical, and third root times third root, I can multiply the x's, so x squared times x to the 4th is x to the 6th, and I'm going to rewrite the x to the 6th as thirds to see that I have 2 perfect thirds. So I'm going to bring out an x and another, which makes it x squared, and I have nothing left in the radical, so it's a nice perfect square, or perfect cube. Alright, last slide. You are going to subtract, and remind yourself to subtract, you have to have like bases, so gh to the 1/4, gh to the 1/4, and I do. So 3 of these minus 8 of those would be negative 5 of those, gh to the 1/4. And the last one, you have 5 to the 1/3 times 100 to the 1/3. So they are both to the same exponent of 1/3. So I can multiply that together and make it 500 to the 1/3. And then I'm thinking perfect thirds, so 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, and I'll stop there because I know that 125 goes into 500, so that's really 125 times 4, all still to the 1/3. And now I know that the third root of 125 is 5, so this is really 5 times 4 to the 1/3, and I don't know the third root of 4, and that's as far as you can take it.